Welcome back everyone to the Hello World Guy, and this is episode number 9 of the 3D platformer series. And in today's video we are going to implement a small enemy AI for our game, because currently only collecting points is not that fun. By the way, one thing that I have already added is that whenever you actually reach the end screen, the game is automatically resets the actual level count. You can add this feature if you want. It's pretty easy. I won't really show you that right now. And what I'm going to do is I'm going to select this portal here, and I'm going to open up the portal script, because firstly I want to implement a system in which if for example, let me show you. So currently if I just hit the play the game, and you can see that I have got my coin there, and if I just ignore the coin and I go ahead and I go through the portal, then it kind of just works, which shouldn't really happen. So in order to fix that, I'm going to open up VS Code here. In here, what we are going to do is, let me just increase the size of this a bit. In the portal method, what we are going to do is that I'm going to well, let's just go ahead and say okay. So what we will need to do is that we will need to say player 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 is equal to other dot get component player player. Come on. All right. And once we do that, we just check if player is equal to now, then we just return. All right. With that, what we need to do is we basically need to we can remove this code now, and what we can do is that we only need to do this if our player dot by the way, if I open up the player script here, you can see that in here we have got no way to access the actual coins amount. So I'm going to add in a go up here, and I'm going to add a public int called coin here. This is going to be read only, and this is going to return the coin variable. Yeah, just like that. Okay, this looks pretty awesome. And what we are going to do is that we are going to check if player dot points is let's just do greater than or equal, even though we don't need to do that. Just equal checking should be enough actually, but we are going to do greater than or equal anyways. We are going to say game object dot get find object of type, and then we are going to say coin, and then we are going to do this, and then we are going to say dot length, because this returns an array, and we can just check the length of that array in order to find out whether we actually need to come on. All right, okay. We can just check the length of that array to find out whether we have actually got the number of coins present in the game right now, and this should actually work. So if I just remove, by the way, game object, does it work? It actually does, I think so. Yeah. Anyways, going here, let it compile, and hopefully everything will be right. Yeah. Anyways, let's just let it compile, and once it has done that, all we are going to do is we are going to hit play and see how well it goes. So if I just go here and I try to okay, and I try to go through without collecting a coin, you can see it doesn't work, even though I don't get a proper feedback. But it doesn't work. And if I try to collect a coin and then I go, then it works. By the way, one better method to do is, I just realized, would be to just check if this length is equal to 0. And yeah, that is basically going to work, because we are just checking if it's 0, which means that there is currently no point in the scene. So yeah, this is pretty nice, and this should work, and that's awesome. But there is one more thing which I would like to do, which is we want to, in the start method of the player class, what I'm going to do is I'm going to have another reference first of all. So let me just go up here where I can actually see. It's a bit of a messy code. Let me just find the coin header, and in here you can see we have got this. I'm just going to duplicate this line. By the way, you can do that by pressing shift alt and down or up arrow or whatever. In here I'm going to say total coins text, like that. And what we can do is we can actually go down here, and once we are doing this in the start method, we can say total coins text dot set text, and we can set the text to be this. uh, let me just say this. All right, and yeah, you can see that this we have to do dot to string here in order to make it actually work. And this should practically well, it should actually work because now it's going to set the actual that text as well. Now of course we need to actually create this text because currently we do not have it in our canvas. So all we need to do is we need to go under the canvas, and I'm just going to duplicate the coin text. Actually, wait a second. We actually do not need to do that. We can just say plus this. We can just add the actual amount to this. So we are going to say something like all right, and in here we are going to add in a slash, then that should work. And it is not being able to convert from, okay, add a plus here. Yeah, that works. So with that done, I think it should work. Of course we need to just copy this text, and we can need to add that to our increase coins function as well, and this should work. And we do not require, okay, let me just remove this reference now. This is a better way, I just realized. And yeah, now it's going to just show the text in here. And to give you a demo, it's going to look something like this out of 15. So if I go ahead in the game and I play the game right now, I should see that it says 0 out of 1 first of all. And currently if I try to go in here, you can see it doesn't work. But if I go and collect a coin, then I go, it worked. So yeah, this is pretty nice. You can see it saying you finished the game. That's because I'm playing the level in between, and I need to clear the preferences in order for it to actually move on to the second level. But this should not happen in the actual game. So yeah, this is pretty nice, and we have got a practical a fine coin collection system working in our game now. Alright, so now it is time for us to implement the actual enemy system, and here I have, just to save time, I have created the enemy already. I have created a sphere called enemy, and I have added a small cube for the glasses of the enemy, and I have applied materials to them. So yeah, this looks pretty awesome, and I think now we will implement the actual logic. I'm going to increase the scale of the enemy, by the way, to 1.5 because I feel like it, and I'm just going to move it up a little bit. That looks alright, I guess. Yeah, that looks pretty awesome. And yeah, now with that done, we actually need to make the enemy well work. And how exactly are we going to do that? Well, we are not totally sure right now. Now we can do two things. We can either make a nav mesh system, or we can use our own system for the enemy. Now I'm going to use our own system because this is just a normal kind of game. It's just a small game with not so much obstacles that the enemy needs to avoid, and it doesn't really matter that we need to add too much stuff to it. So yeah, we are just going to keep it normal, and I'm going to start off by adding a widget body to this. And if I go ahead and I hit play right now, the enemy should roll over and fall down because, well, that's what it's supposed to do. Okay, it didn't. Okay, it does. Oh. That is kind of a little dangerous. But anyways, you can see that now if I just go ahead and I select my enemy, and I make sure that the rotation is freezed on every single axis, and then I hit play, then it should actually start to look pretty good. And you can see that okay, the enemy falls down when the platform gets smaller. Now these are going to be extremely primitive enemies. Like in most platformer games, they will not care about the ground shortening and then falling off. So yeah, that's the kind of enemy. But I am thinking now, right now, that it would be better if this was a kind of a flying enemy. Maybe you can implement that, and that would prevent us from having to create a bunch of gravity logic and stuff. So yeah, I'm just going to do that, and go under the scripts folder, right click, and create a t-shirt script called enemy. Then just go ahead and drag this and put it on the enemy. Okay, let's compile first because you need to do that, of course. And once it has done that, just take the enemy and drag it onto the enemy, and double click to open it up in VS Code. Remove the top to using tag, and I do not think we need these methods right now. So yeah, now how is our enemy going to behave? So in here, I think we need to add the update method back because, well, we need it. And in here, I'll define a couple of variables first, which is going to be a serialized field, a private, float called range. Now this will represent the range of the enemy, that the enemy can see to that range. So I will just we will put it in the inspector, and what we are going to do in the update method is that we are going to, well, before we do any of that, we need to find a reference to the player. So for that I'm going to have a private player called player, and here I'm going to add the start method back as well. I suppose I shouldn't have really deleted it, but anyways, in here we are going to do something really simple. We are going to say player is equal to find object of type player. All right, it's as simple as that. And it will find the first object of type player, and once we do that, we can go into the update method, and we can go ahead and say if we are going to use vector3 dot distance here to find the distance between two vectors, and for the first vector we are going to say transform dot position, and for the second vector we are going to say player dot transform dot position. All right, and then if this is the case, if this distance is greater than or equal to our range, then that means that we are supposed to, well, do it. And for this, all we need to do is, it's very simple. All we need to do is that we need to say we need to, well, wake the enemy up. For this I'm going to add a private bool here called active, and in here we are going to actually let me just change this to awake, because it might cause a little bit of problems. And in here I'm just going to say awake is equal to true. Come on, awake is equal to true. Okay, and once we do that, in here we are going to, well, add our logic later, but first let me just go ahead in the actual in another, well, the point is that I'm trying to create a new method here, because well, even if I go under my unity here and I try to change the range of the enemy by, well, let me just wait for the while, by selecting the enemy and then trying to change the range, you can see I can't really see the range, and I will have to test again and again to just kind of approximate what the range is supposed to be. But for example, in the case of the sphere collider, you can clearly see the actual shape of the collider, which is really awesome. So what I'm going to do is I'm going to open this script up, and in here I'm going to add a function here called on draw gizmos. Now what this does is that this function is called whenever we need to draw extra stuff the screen, like the gizmos, basically like this light icon and all of that stuff. So what we can do in here is that we can say debug dot draw sphere okay, we need to basically draw a sphere here to let us know when it actually happens, when the range changes. So we need to make it sure that, and in here to actually draw it, we need to say gizmos, actually not debug, gizmos dot draw. You can draw a bunch of stuff. I'm going to draw a sphere here, and for the vector we need to give it a center, which is obviously going to be transform dot position, and a radius, which is going to be our range here. Very simple, and this is actually going to work. So let me just go to Unity and let it compile. Come on, and yeah, let's just wait for it to compile. And once it has compiled, you can see I can change the range, and this is kind of what it draws, which kind of looks terrible. So we do not actually want that. So if I open up the Visual Studio again, you can see we have got Gizmos draw sphere here. So if I open this up, you can see it looks like that. But if I change this to draw wire sphere, then let's go ahead and see what that looks like. And yeah, let's see. Okay, that looks a lot better. Now we can actually see the range that we have. I'm going to increase it to something like 4, maybe 4. Yeah, that looks awesome, and yeah, that should actually work. So this is going to work. Of course, we are going to have our enemy be awake when we want it to. So in here we actually need to okay, I'm not going to do that. We are going to go ahead and check. I'm actually going to press tab to get this in here, and I'm going to add in this here, and I'm going to put this in an else block. And then what I'm going to do is go up here and say if let's just say let's say if our enemy is awake, then we are going to well, do this code here, else we are going to execute all of this. Now in here you might want to create a new function here called logic, called actually let's call it chase player, and let's create this function because it currently does not exist, and just a private void. And all we need to do in this function is we need to find a direction to the player, then we need to rotate ourselves to that direction, and then we need to move to that direction. So for that I'm going to say, we are going to of course define a speed because we need to do that. Private float called speed. Alright, and what we are going to do in here is we are going to say we need to find first of all a direction. So for that I'm going to say vector3 direction is equal to trans. You need to if I am right, you need to subtract this minus the player dot position. If I'm not wrong, hopefully I'm not. And let's see, and player dot transform dot position. And after calculating this, we need to actually normalize this direction that we have calculated. So I'm going to say dot normalize. All right, once you have done that, so all we need to do is we need to say we need to actually turn ourselves to look at that direction. So I'm going to say transform dot rotation is equal to quaternion dot loop rotation, and for this I'm going to say direction, and this should actually work. So let's go under here, and let's just see if loop rotation takes a forward. All right, so let's compile and go under Unity. Let's open up the game and hit play, and hopefully everything will work. Oh, so you can see that, okay, I am in the range when the game starts, and you can see that it's kind of working. Wherever I go, the enemy is always facing me, which makes a lot of sense. So yeah, now that's pretty awesome. So yeah, this is an error. We will fix that in a second. So yeah, we will. That's pretty much great for our enemy, and we're going to implement the rest of the enemy logic in the next video because this video is getting pretty large. So yeah, I will see you in the next one. Make sure to like and subscribe, and I will see you in the next one. Bye.